Okay. Now the next for sorted set. Sir, can you please explain demo program? You can't, because the reason is sorted set is an interface. If it is a class, I can create an object and then I can, but sorted set is an interface. That's why there is no demo program like here. So we covered this one, set, and then what? Sorted set we covered. What is the next interface? Navigable set. Now 1 minute. So this navigable set I will cover at last as 1.6 version enhancements, like at the separate heading I will discuss this one. Okay, this I am not talking at this stage. Now what is the implementation class for this? TreeSet. TreeSet. Now we have to talk about TreeSet concept, right? Now keep submitting. TreeSet implementation class for sorted set, of course. TreeSet. TreeSet. This part we have to discuss. Navigable set at last I will cover as 1.6 version enhancements like. So point is a TreeSet. TreeSet. Okay. Now TreeSet first conclusion here is take a bit special care. Underlying data structure for a TreeSet is balanced tree. And underlying data structure for TreeSet is what? Balanced tree. Okay, this is. Now duplicates are allowed or not allowed? Not allowed. Insertion order preserved or not preserved? Not preserved. Because sorting order, all objects will be inserted according to some sorting order. That's why insertion order not preserved. Next, heterogeneous objects are allowed or not allowed? Heterogeneous objects allowed or not allowed? Allowed or not allowed? Not allowed. Have you remembered? Only two data structures except a TreeSet and a tree map. Everywhere heterogeneous objects are allowed. But in TreeSet, heterogeneous objects are not, because comparison must be required. If you want to perform comparison, both objects should be same type. Okay, these are different objects. That's why heterogeneous objects we can't insert. By mistake, if you are trying to insert heterogeneous objects, then we will get a class cast exception, right? Okay, remember, then we will get what? Class cast exception, right? Okay, this is. Next, null insertion possible or not? Is nothing but possible. Null insertion possible, but how many times is nothing but? Only once. But there is a big story is there about null. As a separate heading I will discuss, but default null insertion is possible, but how many times is? Only once. Clear for all of you, right? Okay, at these points first. The first point, the underlying data structure is balanced tree. Underlying data structure is balanced tree. Next, second point, duplicate objects are not allowed. Duplicate objects are not allowed. Duplicate objects are not allowed. Next, insertion order not preserved. Insertion order not preserved. Next, heterogeneous objects are allowed or not allowed? Heterogeneous objects are not allowed. Otherwise means what? If you are trying to insert heterogeneous objects, otherwise we will get runtime exception saying. Saying class cast exception. Otherwise we will get runtime exception saying class cast exception. Next, null insertion possible or not? Null insertion possible within bracket only once. Null insertion is possible within bracket only once. Clear, right? Next, all here 1 minute implements serializable, clonable. Here also every collection already implements serializable, clonable, but not random access. Add TreeSet implements serializable. TreeSet implements serializable and clonable. TreeSet implements serializable and clonable, but not random access. Serializable and clonable, but not random access. But not random access. Okay. Next, all objects will be inserted based on some sorting order. It may be default natural sorting order or customized sorting order. Both options are there. How we can implement that part I will discuss anyway. Add all objects will be inserted based on some sorting order. It may be default natural sorting order. It may be default natural sorting order or customized sorting order. Now both options, it may be default natural sorting order or customized sorting order. Okay. Next, let me go for a small demo program and then I will explain some more conclusions, right? But before that, let me explain constructors first. Add constructors. Okay. So here see, these constructors are very, very important. Here observe, because even in the next classes we are going to cover sorted map, tree map, like same terminology, copy paste. That's why you should take special care. If you can able to understand here, in the future the remaining things will become easy for you. Now TreeSet T is equal to new TreeSet. Sir, TreeSet T is equal to new TreeSet. So it creates an empty TreeSet object where all objects will be inserted according to default natural sorting order. Are you getting? Where all objects will be inserted according to what? Default natural sorting order is nothing but like first one. Now the second, TreeSet T is equal to new TreeSet of, okay, here say these constructors are very important. TreeSet T is equal to new TreeSet of comparator C. Just if you pass comparator object, have you observed the difference? Here no argument constructor, but here which one is the argument? Comparator. So creates an empty TreeSet object where the objects will be inserted according to customized sorting order. That customized sorting order can be specified by comparator object. Now simple word, in the next classes I will explain comparator meant for customized sorting order. There is one more concept is that named with comparable. That part we will discuss soon. Comparable meant for what? Default natural sorting order. Wherever comparator is there, customized sorting, our own sorting we are implementing, like, okay, add first one. So can you tell, if I want to use default natural sorting order, can I go for first one or second one? First constructor, no argument constructor meant for default natural sorting order. Comparator argument constructor meant for customized sorting order. Remember this thumb rule, because we are going to use minimum 10 times these two words. Okay, add first one. TreeSet T is equal to new TreeSet bracket open bracket close. TreeSet is equal to new TreeSet. Okay, add creates an empty TreeSet object. An empty TreeSet object where the elements will be inserted according to, where the elements will be inserted according to, elements will be inserted according to default natural sorting order, where the elements will be inserted according to default natural sorting order, where the elements will be inserted according to default natural sorting order, default natural sorting order. Okay, first one. Second, TreeSet T is equal to, TreeSet T is equal new TreeSet of, TreeSet T is equal to new TreeSet of, new TreeSet of comparator C. TreeSet T is equal to new TreeSet of comparator C, comparator C, comparator C. Okay, add creates an empty TreeSet object, creates an empty TreeSet object, creates an empty TreeSet object where the elements will be inserted, where the elements will be inserted, where the elements will be inserted according to, where the elements will be inserted according to customized sorting order, where the elements will be inserted according to customized sorting order, customized sorting order specified by customized sorting order specified by comparator object, specified by comparator object, comparator object. Okay, so this is the second constructor we have. Next, third and fourth constructors are there, but anyway normal, not required to give that much importance for this. Now TreeSet T is equal to new TreeSet of collection C. Have you observed? New TreeSet of collection C. You know, for interconversion between collection objects, this constructor. Fourth one, here see. Fourth one, TreeSet T is equal to new TreeSet of, okay, for any sorted set object, any sorted set, if any other sorted set is there, for any sorted set object, equivalent TreeSet by default will be created. Are you getting that? Okay, this is. So based on which sorting, same sorting is implemented in this TreeSet. Are you getting right? But here have you observed normal collection, so default natural sorting order is going to be considered. Okay, remember this one. So based on this sorting, here sorting will be there, but here just any normal array list object, so it never talks about sorting, then default natural sorting order by default will be considered. Okay, these are remaining two constructors also. Just add TreeSet T is equal to, TreeSet T is equal to new TreeSet of, TreeSet is equal to new TreeSet of collection C. TreeSet is equal to new TreeSet of collection C. Next, TreeSet T is equal to new TreeSet of, TreeSet T is equal to new TreeSet of sorted set S. TreeSet is equal to new TreeSet of sorted set S. Sorted set yes. Are you getting? So total how many constructors are there? Okay, four constructors we have. Not required to keep much explanation about this terminology, right? Are you getting the point, right? Okay, so now let me convert this total discussion into a small example form, and where I will explain some more concepts after this example. Just observe, listen. So 1 minute. Here I am taking TreeSet demo. TreeSet demo, minimum 5 or 6 programs we are going to discuss. Okay, almost around 3 to 4 hours I will spend only on the TreeSet. That's why make sure you should have clarity. Okay, here I am taking TreeSet is equal to new TreeSet. And now 1 minute, listen. TreeSet is equal to new TreeSet. Okay, T dot add of here have you observed? Is it default natural sorting order or customized sorting order? Default, because which constructor we used? No argument first constructor meant for default natural sorting. Sir, T dot add of A, B, Z, L. Forget about commented lines. SOP of T. Can you tell what answer we are going to get now? What is the answer? Small a, capital A. Which is bigger, which is small? Small a, capital A. Which is bigger, which is small? Okay. Make sure small a is bigger than capital A. Because small a Unicode value is 97, but capital A Unicode value is 65. Observe the difference. Are you getting? That's why small a is bigger than A, B, Z, L. Okay. So that's why first which thing we will get? A we will get capital A. And then what? Capital B. And then capital L. And then capital Z. And then small a, right? Can are you able to understand? Where all objects will be inserted according to some sorting order. Are you getting? According to some sorting order. So now Java C TreeSet demo.java. Clear? Java TreeSet demo is nothing but like Java TreeSet demo. Have you observed? For the output by default you are going to get A, B, L, Z, A is nothing but like correct or not? Okay, this is so the output we are going to get. But here just observe which type of objects we are trying to add. Which type? String object. But now I'm trying to add okay, new integer. Integer means what? Heterogeneous objects. Are you getting? Integer and string heterogeneous. If I'm trying to insert heterogeneous objects, what will happen? Class cast exception, right? Now whether I'm going to get class cast exception or not. Here say exception in the thread main. What is that exception? Class cast exception, right? Not required to keep any explanation. That's why is nothing but now commented line. Next t.add of null. T.add of null. Sir, here just observe null related to that. There is a big story is there. That part I will discuss after completing this example anyway. So first take this example, including commented lines also. Take clearly. TreeSet demo. Public static void main. TreeSet is equal to TreeSet t.add of a like completed, I hope. TreeSet t is equal to new TreeSet t.add of a, b, z, l. Like better to take commented lines also. Completed, right? Okay, so better to, I hope you people took the output also, a, b, l, z, a. Okay, just so observe, keep subheading null acceptance. Null acceptance. There is a big story is there about null acceptance. So just observe null acceptance. So related to null acceptance, there are multiple loopholes are there. What the loopholes here is, listen this one. Sir, if the for the TreeSet already I added some elements. A I added, B I added, C I added. Now I am trying to insert a null. Sir, listen this one. I am trying to insert null. In TreeSet, while adding objects, compulsory comparison must be required. Are you getting that? Compulsory comparison must be required. Sir, here null I am trying to add. Where we have to place null? Sir, before A or after A? So compulsory null is required to compare with the already existing element. Correct or not? If we are trying to compare with a null, any object with a null, immediately null pointer exception we are going to get. Are you getting that? That's why for non-empty tree set, sir, my tree set is non-empty. For non-empty tree set, if we are trying to insert a null, sir, my tree set already contain how many elements? 3 elements. Now at the 4th element I am trying to insert null, immediately we will get null pointer exception. Are you getting null pointer exception, right? So first point is clear. For non-empty tree set, if we are trying to insert null, then what will happen is a null pointer exception. Okay. Now second one. Suppose tree set is empty. Tree set is empty. Sir, we are not adding anything. So my empty tree set, I am trying to insert null. For empty tree set, if I am trying to insert null, first element, for the first element, comparison is required or not required? No, comparison is not required. That's why for empty tree set, if we are trying to insert null as the first element, no problem at all, acceptable. But the problem here is up to null, okay, well, t dot add of null, acceptable, no problem at all. But whenever we are trying to insert second element, now t dot add of a I want to insert. Now I have to compare a with the null. If I am trying to compare a with null, then what will happen once again? Null pointer exception we are going to get. Are you getting? Let me repeat once again. For non-empty tree set, if we are trying to insert a null, okay, we will get null pointer exception. But for empty tree set, yeah, the first element, if we are trying to insert null, acceptable. But after inserting that null, if you are trying to insert any other element, we will get what? Null pointer exception, right? Clear for all of you up to this, right? Okay, this is. So first here, listen, let me show first this one. Here I am taking tree set is equal to new tree set. Tree set is equal to new tree set. There are some elements are there. Now I am trying to insert null. Sir, for non-empty tree set, if I am trying to insert null, what will happen? What will happen? Null pointer exception we are going to get. Now here see, sir, let me save. The code compiles fine. What is the answer? Null pointer exception. Any explanation is required? Null pointer exception. Suppose, sir, my tree set is empty. Sir, all are commented lines. Only one line, t dot add of null. Sir, only one line, t dot add of null. Null means what? First element. Is it acceptable or not? Yes, boss. For empty tree set as the first element, null acceptable, no problem at all. But after inserting null, if I am trying to insert any other, sir, t dot add of a I am taking. Is it valid or invalid? Invalid. Immediately null pointer exception by default we are going to get. Are you getting? Null pointer exception by default we are going to get. Any explanation is required, Anna? Okay, make sure. So rules are very clear. For non-empty tree set, if we are trying to insert null pointer exception. But for empty tree set, yeah, the first element, null insertion is possible. But after inserting that null, if you are trying to insert any other null pointer exception, we will get. Clear for all of you, right? Okay, add null acceptance under the first rule. For non-empty tree set, if we are trying to insert non-empty tree set, if we are trying to insert null. For non-empty tree set, if we are trying to insert null, then we will get null pointer exception. For non-empty tree set, if you are trying to insert null, then we will get null pointer exception. We will get null pointer exception. Okay, first one. Second point. For empty tree set, as the first element, For empty tree set as the first element, for empty tree set as the first element, null is allowed. For empty tree set as the first element, null is allowed. For empty tree set as the first element, null is allowed. Null is allowed. But after inserting that null, after inserting that null, if we are trying to insert any other, but after inserting that null, if we are trying to insert any other, then we will get runtime exception. Saying, then we will get runtime exception saying null pointer exception. We will get runtime exception saying null pointer exception. Okay, that's all. Any explanation is required about this one? So null itself is the clear. But now take a bit very special care. Okay, so which version of Java I am using? And here legend, have a look once. Java hyphen version, like I am taking. Which version I am using? 1.6 version. 1.6 version I am using. But now let me go for 1.7 version. 1.7. Anyway, here see, sir, remove. Can you tell in the 1.6 version, is it valid or not? Valid, because how many elements we are inserting for the tree set? Only one. What is that element? Null. For empty tree set as the first element, null insertion possible, no problem at all. If you want, you can, 1 minute, sorry. If you want, you can compile, and if you run this code, null is the answer. Correct, null itself is the answer. But the same program, let me run in 1.7 version. Okay, now here see, this is, let me cross check, Java hyphen version like, I'm taking. Have you observed which version I'm using? 1.7 version. Now the program is the same program, Java C TreeSet demo.java, compiles fine. Let me run this code. Run this code. Have you observed? Null pointer exception we are getting. Observe the point clearly, right? So version to version there is a difference. From 1.7 version onwards, even the first element also null is not allowed. Are you getting? Null, such type of story not applicable for the tree set. From which version onwards? 1.7 version onwards. API small difference is there. Take a note with a star. Note, keep star a bit important. Not with a star. Add. Until 1.6 version, null is allowed. As the first element, null is allowed as the first element. Null is allowed as the first element to the empty tree set. Null is allowed as the first element to the empty tree set. Null is allowed as the first element to the empty tree set. To the empty tree set. But from 1.7 version onwards, null is not allowed. Even as the first element. Null is not allowed even as the first element. Okay, that is null. Better to take within single quotes or double quotes. Null within single quote. Null, such a type of story. Not applicable for a tree set. Null, such a type of story not applicable for a tree set. Not applicable for tree set from which version? From 1.7 version onwards. null, such a type of story not applicable for TreeSet from 1.7 version onwards. Okay, that's all. So the terminology is very clear for all of you. So make sure this is about null acceptance, right? Are you able to understand? I hope in this example you saw sorting order. Sorting order you saw. If we are trying to insert heterogeneous objects, what will happen? What will happen? If we are trying to insert heterogeneous objects, what will happen? Class cast exception. Next, what about null story? Null story, there is a big story is there related to the TreeSet. Okay, that's all. Now we will go for second example. Like take a bit special care. So now the next example. So the first example we covered already. Okay. So can you spell out? Is it possible to add heterogeneous objects to the TreeSet or not? No. By mistake, if you are trying to add heterogeneous objects, what will happen? Class cast exception, right? So for the TreeSet, we have to add only homogeneous objects. Correct or not? Okay, this is. Now let me go for a simple example. TreeSet demo. Okay, TreeSet demo 1.java. Here see. Now very simple example. In the last example, which type of objects we added? String objects. Correct or not? But in this example, which type of objects we are adding? Which objects we are adding? String buffer objects. String buffer objects we are adding. Are you getting? So string buffer objects, these objects are homogeneous objects or not? These objects are what? Homogeneous. That's why there is no problem at all. Like now, can you tell what is the output by default we are going to get? If I can take like this, if I can take this program, what is the output we will get? A Z L B or A B L Z or Z L B A. I am trying to add which type of objects? String buffer objects, right? All objects are homogeneous objects or not? Yes, all objects are homogeneous objects only. Then can you tell what output by default we are going to get? Is it so A Z L B or A B L Z or Z L B A? Which one is the correct answer? A B L Z. Oh, alphabetical order, right? Okay. For the string objects, default natural sorting order is alphabetical order. But for the string buffer, what is natural sorting order? Who told you it is ABLZ? Ayo. What is the output by default we are going to get? ABLZ or ZLBA? The people who attended already be silent. Otherwise recommended to go out. Okay. So Java C TreeSet demo 1.java. Okay, this is TreeSet demo 1.java. Now, so if I can take like this TreeSet demo 1, can you tell what is the output by default we are going to get? Yes, ABLZ or ZLBA. Yes, what is the output by default we are going to get? Make sure all are homogeneous objects or not. All are homogeneous objects. That's why is there any chance of class cast exception? No, because if we are trying to add heterogeneous objects, then we will get class cast exception. But I am not adding any heterogeneous objects. I am adding only homogeneous objects only. What is the output by default we are going to get? Can I spell out ABLZ or ZLBA? ABLZ. Are you able to understand, right? Now just observe. If I am trying to take like this, immediately we are going to get, okay, if I am trying to take like this, immediately we are going to get, have you observed class cast exception, right? Are you getting what exception we are getting? Class cast exception. Okay, make sure you should aware. Sir, why? What is the problem? We added only homogeneous objects only. Okay, we added only homogeneous objects only. Why we are getting class cast exception in this case? Make sure you people should remember well. Sir, in this example, am I depending on default natural sorting order or customized sorting? Default natural sorting, because which constructor we used? First constructor, TreeSet is equal to new TreeSet. Okay, default natural sorting order, right? Okay, make sure if we are depending on default natural sorting order, compulsory the objects should be homogeneous, compulsory the objects should be homogeneous and comparable, homogeneous and comparable. Are you getting? So when we say that an object is said to be comparable if and only if the corresponding class implements comparable interface. Are you getting? String objects are comparable. So string buffer objects are not comparable. Remember the word, right? Okay, sir. Yeah, if we are depending on default natural sorting order, compulsory the objects should be homogeneous. Rule number 1, homogeneous and comparable. Okay, if any condition fails, sir, if you are trying to add heterogeneous objects or if you are trying to add non-comparable objects, then we will get runtime exception saying class cast exception. By default we are going to get, so what exception we will get? Class cast exception, right? Are you getting? So in this example, in the last example, which objects we added? String objects are homogeneous, of course, only string object, and comparable because string class already implements comparable. But string buffer, in the current example, string buffer, homogeneous objects only we are adding, but the string buffer objects is not comparable. That's why we are getting class cast exception, right? Are you getting? Just observe this point well. Yeah, TreeSet is equal to new TreeSet. Okay, t dot add of new string buffer of a, z, l, b, all are string buffer objects only. Okay, here exception in the thread main, class cast exception, java.lang.string buffer. Observe the description. String buffer cannot be cast to comparable. Are you getting? Cannot be cast to what? Comparable. That's why the problem is coming. Sir, if we are depending on default natural sorting order, compulsory the objects should be homogeneous and comparable. String objects are, in the last example, have you observed? We added only string objects. T dot add of, like, we added only string objects. String objects are comparable, but string buffer objects are not comparable. That's why in the last example it is the valid, but in this example we are getting class cast exception. Any explanation is required, na? When we say that an object is said to be comparable if the corresponding class implements what? Comparable interface, right? Now let me consider this one. Java java.lang.string. Let me check the profile of string. java.lang.string. Here have you observed? Public final class java.lang.string extends what? java.lang.object implements serializable comparable. Are you getting? String objects are comparable objects or not? Yes. Okay, let me consider same thing with respect to string buffer. Sir, same java.lang.string buffer. Okay, let me check. So string buffer, have you observed? Public final class string buffer extends abstract string builder implements serializable char sequence. That's all. Only two interfaces here. Where is the comparable? Comparable is not there. That's why we are getting, okay, that's why we are getting what? Class cast exception, right? Any explanation is required about this terminology now? Okay, make sure what is the reason for that. Okay, take this example first. Yeah, this is the example 2. Seems to be very easy, but there is a big concept is there. Import java.util.star class TreeSet demo 1. Next, t.add of new string buffer of a, t.add of new string buffer of z, new string buffer of a, new string buffer of z, new string buffer of l, new string buffer of b, new string buffer of b, l, and then new string buffer of b, and after that SOP of t, like this. SOP of t. TreeSet t is equal new TreeSet. T t dot yard of new string buffer of a, new string buffer of z, l b SOP of t. Completed, right? SOP of t, t like this, a z l b like. So can you tell what will happen? We will get add runtime exception saying class cast exception, runtime exception saying class cast exception. Okay, what is the reason? You know, not required to keep explanation. Class cast exception. Okay, now add the theory. If we are depending on default natural sorting order, compulsory the objects should be homogeneous. Compulsory the objects should be homogeneous and comparable. Compulsory the objects should be homogeneous and comparable. Otherwise we will get runtime exception. Saying class cast exception. Okay, sir, can you tell when we say that an object is said to be comparable? When we say that an object is said to be comparable, if and only if the corresponding class implements what? Comparable interface. Are you getting? If and only if corresponding class implements comparable interface. Do you know string class implements comparable or not? Yes. Okay, string buffer implements comparable or not? No, string buffer doesn't implement comparable. All wrapper classes, you know, byte class, integer class, like two integer objects happily you can compare, two float objects you can compare. That's why, so all wrapper classes are comparable, right? Are you getting? So but string buffer doesn't implement comparable. Okay, at this point an object is said to be comparable. An object is said to be comparable. Comparable if and only if. An object is said to be comparable if and only if corresponding class implements. Corresponding class implements comparable interface. If and only if corresponding class implements comparable interface. Next, string class and all wrapper classes. Wrapper classes already implement. String class and all wrapper classes already implement comparable interface. But string buffer class doesn't implement. Comparable interface. But string buffer class doesn't implement comparable interface. String buffer class doesn't implement comparable interface. Okay, hence hence we got class cast exception. Hence we got class cast exception in the above example. So what is the reason why we are getting class cast exception? Now I hope you know the reason. Hence we got class cast exception in the above example. We got class cast exception in the above example. Okay, that's all. So now the terminology is very very clear for you people anyway, right? Now the next point, take very very special care about this terminology, right? Here, what about comparable? Comparable present in which package? Oi, comparable interface present in which package? Java.lang. Comparable interface contain how many methods? Only one method. Compare to method. It contains only one method. Okay, present in lang package. It contains only one method. Compare to method, right? Okay, now keep studying comparable interface. Now we have to talk about comparable interface within bracket I. Comparable interface. Okay, add. It is present in java.lang package. It is present in java.lang package, lang package, and it contains only one method. What is that method? Compare to. And it contains only one method. Compare to. Only one method. Compare to. That's all. Now the next one, take very very special care. What is the meaning, or what is the ERC? What is the complete syntax of compare to method? Sir, I have two objects are there. Two objects are there. obj1 dot compare to of obj2. Assume that if I compare two objects, how many possible results are there? Have you observed? obj1 can come after obj2, or obj1 can come before obj2, because comparison, which one should come first, which one should come last, is nothing but for that we have to use compare to. obj1 can come before obj2, or obj1 can come after obj2. Next, obj1 and obj2 may be equal, is nothing but like. So how many results are there? 3. So obj1 should come before obj2, or obj1 should come after obj2, or obj1 and obj2 both are equal. Equal means duplicate. Duplicates are not allowed in the tree set. That's why how many options are there for us? 3. So that's why the return type of compare to method is not a boolean. If it is a boolean, how many options we can cover? Only 2. But here how many options are there? 3. That's why the return type of compare to method is int. So public int compare to of object obj. Compare to of object obj is nothing but like this is compare to method. Now point number 1. So int means, for the int, how you can decide three categories? Simple. Negative number means one category, positive number means another category, 0 means third category. Are you getting that? Okay, negative, positive, 0, 3 options we can able to cover. Now observe this one. Sir, I want to call obj1 dot compare to obj1 dot compare to of obj2, obj1 dot compare to of obj2. Sir, here take special care. Returns negative. Sir, how much negative value? Maybe -1, -100, -1000, -10,000, all are equal. So value is not important, sign only. Returns negative if and only if obj1 has to come, obj1 has to come before obj2. Before obj2. Sir, if obj1 has to come before obj2, then this method returns what? Negative. Negative value, right? Returns negative. Next, here say returns positive. Returns positive. Can you tell when it returns positive? You can able to guess. If and only if obj1 has to come after obj2. Was positive means after, negative means before. Next, when it returns 0, returns 0, if and only if obj1 and obj2 are equal. Returns is nothing but obj1 and obj2 are equal, is nothing but like. Are you getting? So make sure you people should have clear clarity. Okay, obj1. So when it returns negative, when it returns positive, when it returns 0, compulsory you people should have clarity. Do you know? After this comparable, next we are going to discuss comparator. In the comparator there is one method, compare method is there. The same concept there copy paste. That's why if you able to understand this terminology, so the next things will become a bit easy for you. That's why make sure you should have clear clarity. Can you tell obj1 dot compared to of obj2 returns a negative? What it means? obj1 should come before obj2. Returns positive. What it means? obj1 should come after obj2. Returns 0 means what? obj1 and obj2 are equal. Boss, duplicate, don't insert, something like. Okay, yeah, these are things. Take syntax followed by this total thing. Very important part. So now I hope this one you people got clearly. Just let me explain with a small example. Forget about TreeSet, all these things. First you people should have clear clarity on the behavior of this comparative method. Okay, what I will do here is just observe. I hope visible, right? Okay, just here see system.out.println. Sir, SOP of A is which type of object? String. String already implements comparable, and for the string compare to capability is there, but for the string buffer compare to is not there. On A I am calling compare to of Z. Have you observed? On A I am calling compare to of Z. Sir, I am comparing A and Z. Can you tell in alphabetical order A should come before Z or after Z? Before. Before means is it going to return positive or negative? Negative. So the answer we will get a negative. I will execute and I will show anywhere, right? System.out.println. Okay, SOP of. Now I am taking Z dot compare to of some K. Z dot compare to of K. Can you tell Z should come after K or before K? After K. After K means what? Positive. Sir, how much positive, how much negative? Value not important, only sign. Sign is important, right? Now system.out.println A dot compare to of A. A dot compare to of A. Have you observed? Both are equal or not? If both are equal, what comparative method return? 0, like. Clear? Next, system.out.println. Okay, anyway, up to this let me consider, and one more SOP I will add. Have you observed with the example the behavior is clear compared to method behavior? Now observe this one, sir. Here let me take one simple example. I'm taking right here. 1 minute, same example. Here see this one. So test.java class test public static void main a dot compare to of z dot compare to of k. Next, and after that a dot compare to of a. Can you tell first case what the answer? First SOP, what the answer? Negative. Second, because a should come before z. Second one, z should come after k. Next, a should come before a. That's why a and a both are equal. That's why 0. First one negative, second one positive, third one 0, right? Okay. Now see this one. Java C test.java. The code compiles fine. Java test. What the answer? First one negative, -25. Don't give importance for 25. Give importance for minus number, negative number. Next, positive number. Last one is nothing but what? 0. Clear for all of you, right? Okay, this. Next, here see just one more SOP let me add, because I may use in the future. A dot compare to of null. Have you remembered somewhere I cover? If you are trying to compare any element with null, if you are trying to compare any element with null, what will happen? Null pointer exception. We are going to get what output is null pointer exception. Have you observed this is first negative positive 0, and then what? Null pointer exception, like. Okay, so in the first case the answer is negative, second case the answer is positive, third case the answer is 0, fourth case the answer is what? Null pointer exception. Clear for all of you, right? Okay, take this. So I hope up to this you took, right? This one up to this you took. Now take this example from the screen. Take the example from the screen. Class test public static void main string array args SOP of a dot compare to of z negative number, z dot compare to of k positive number, a dot compare to of a 0. Next, a dot compare to of null. Runtime exception saying null pointer exception. Clear, right? A dot compare to of null pointer exception, right? Okay, now just observe. So you people may have the big doubt, sir, what is the relation between compare to method and the TreeSet? Regarding internally how this thing is happening, what is the link between TreeSet and compare to or comparable? Now listen this point well. So here I am taking, observe a bit very carefully. Here I am taking TreeSet T is equal to new TreeSet. TreeSet is equal to new TreeSet. Sir, creates TreeSet is equal to new TreeSet creates an empty TreeSet object where the elements will be inserted based on natural sorting order, default natural sorting order. Now I am trying to add T dot add of T dot add of K I am trying to add. Are you getting? T dot add of k. K I'm trying to add. For the first element, is there any comparison is required? No, that's why. So first element successfully inserted. Sir, first element no comparison is required. TreeSet, right? K added. Now T dot add of Z I'm taking. Next T dot add of A I'm taking. T dot add of A I'm taking. And then T dot add of K I'm taking. T dot add of K, or otherwise T dot add of A I'm taking. Are you getting? And then system dot out dot println of T. Okay. So just can you tell what the answer we are going to get now? If I can take like this, what the answer? Default natural sorting order A, K, Z. That's all. How many times A will be inserted? Only one time, because duplicates are not allowed. Okay. Now, sir, how we are getting A, K, Z? At the end, just I showed, boss, all objects are inserted based on sorting order. Like that's why A, K, Z, right? Internally, what thing is happening? You should aware how the JVM can decide, boss, A, K, Z is the order. Okay. Simple. For first element, comparison is required or not required? Not required, successfully added. Whenever we are trying to add second element, compulsory comparison must be required. Are you getting? Compulsory comparison is required. Internally, JVM is gone. How the JVM can decide this Z should come before K or after K? So how the JVM can decide? Being human being, we can tell, boss, Z will come after K. But how my machine can decide Z should come after K is nothing. Whenever we are trying to insert objects to the tree set, if we are depending on default natural sorting order, internally JVM will call compare to method. Are you getting? Internally which method will be called? Compare to method, right? Okay. Now how the compare to method will be called? Yeah, do you know? Here it's a big confusion for most of the people. Sir, obj1 dot compare to of obj2. Are you getting? obj1 dot compare to of obj2. Sir, which is obj1? Which is obj2? Here I have to compare Z with K. Which is obj1? Which is obj2? Z is obj1 or obj2? Z is, make sure which object we are trying to insert. Sir, which object we are trying to insert? Z, which is nothing but obj1. Remember this one. So obj1 means the object which is trying to be inserted. Which is trying to be inserted. Sir, which object we are trying to insert? Which object we are trying to insert? Okay, the object which is trying to insert. The object which is to be inserted. Which is to be inserted is nothing but obj1. Sir, which is obj2? Is the object which is already inserted. The object which is already inserted. Which is already inserted is nothing but like. Are you getting? Make sure you people should aware clearly this terminology, right? Okay, the object which is already inserted is obj2, which we are trying to insert obj1. Now, so whenever we are trying to insert Z, internally comparative method will be called. So for string objects, comparable ability is there or not? Yes. If it is a string buffer not there, that's why we are getting class cast exception, right? Now, can you tell which method will be called? Compare to how? Z dot compare to of what? K. Now JVM will call what? Z dot compare to of K, already there. Now can you tell Z will come after K or before K? After K. Now I got what? Positive. Once JVM saw this positive, oh, Z should come after K. Now JVM can decide. Now it is going to place is nothing but Z as the right node. Are you getting? Because the TreeSet right means greater, left means what? Lesser, smaller. Okay, like next T dot add of A. So T dot add of A I'm taking. Now I have comparison must be required. Can you tell how the comparison is going to be happen? Can you tell what is that one? A dot compare to of k, root element ana, a dot compare to of k. Can you tell internally which method will, I mean a dot compare to of k, a should come before k or after k? Before. It returns what? Negative. By seeing negative value, by seeing negative value, a so has to place, a will be placed where is nothing ma, before k a got placed. Are you getting? A got placed. Now observe the diagram ana. Okay, this is next up t dot yard of a. Now once again comparison must be required or not? Yes. Can you tell what is the thing? A dot compare to, a dot compare to of k, root element ana. So a should come before k, that's why returns what? Negative. Returns what? Negative. So I have to place a before at the left, but at the left one more element is there. Once again you have to compare this element with this element, so second comparison also, a dot compare to, a dot compare to of what? A dot compare to of a, what it's going to return? 0. Oh, 0 means what? Duplicate. This object not required to insert. That's all. So now my diagram is what? A k z in order or something like a k z is the output by default. We are going to get right. Any explanation is required, Anna? Simple. While inserting objects into the tree set, internally JVM will call which method? Compare to method, right? That's why if we are depending on default natural sorting order, compulsory the objects should be comparable and homogeneous. If the objects are not homogeneous or not comparable, immediately we are going to get class cast exception, right? Any explanation is required? Okay, this at this point. If we are depending on default natural sorting order, if we are depending on default natural sorting order, then while adding objects into the tree set, JVM will call which method? JVM will call compare to method. Compare to method. Okay, like take this example. TreeSet T is equal to new TreeSet. TreeSet is equal to new TreeSet. T dot yard of k. TreeSet is equal to new TreeSet. T dot yard of k. Next T dot yard of z. T dot yard of k. T dot yard of z. Next T dot yard of a. Take clearly, even compare logic also, which methods internally call. So why compulsory the object should be comparable? Because the reason is nothing but this one. TreeSet T is equal to new TreeSet T dot yard of k. Next T dot yard of z, like T dot yard of k, T dot yard of z. Next T dot yard of a dot compare to of k, a dot compare to of a, like a k z, like we are going to get. Take clearly. So here the terminology is also very important. obj1 dot compare to of obj2. Next, obj1 means the object which is to be inserted, sir, which we are trying to insert. obj1. obj2 means the object which is already inserted. Completed, right? So the most valuable terminology you people should aware clearly, right? So the output we are going to get is a k z, like, okay. So any explanation is required about this one? obj1 dot compared to of obj2, the object which is to be inserted, the object which is already inserted is the same. Now, do you know, sometimes legend this one, have you completed, right? Just observe, sometimes default natural sorting order not already available. Best example for that, string buffer. Are you getting? For the string buffer, compared to capability is not there, that's why default natural sorting order not already available, okay. Or if we are not satisfied with the default natural sorting order, best example, sir, you are trying to insert based on what? Alphabetical order, but I don't want alphabetical order, I want reverse of alphabetical order. Are you getting? If we are not satisfied with the default natural sorting order, then we can go for customized sorting by using comparator concept. Are you able to understand, right? So comparable, compare to, meant for what? Default natural sorting order, okay. This is, sir, we are not satisfied with the default natural sorting order, or if the default natural sorting order not already available, then we can define our own customized sorting by using comparator, okay. Like, sir, very important thumb rule you have to aware in the collection framework. What is the difference between comparable, comparator? Simple word, comparable meant for default natural sorting order, whereas comparator meant for customized sorting order. Are you getting? Take a note. If default natural sorting order, if default natural sorting order not available, if default natural sorting order not available, or if we are not satisfied with, or if we are not satisfied with default natural sorting order, or if we are not satisfied with default natural sorting order, then we can go for customized sorting. Then we can go for customized sorting. We can go for customized sorting by using comparator. Then we can go for customized sorting by using comparator. Are you getting the point? So comparable, comparator. Observe, we can go for customized sorting by using comparator, okay. Now the point is, make sure you should aware, sir, comparable meant for default natural sorting order. Comparable meant for default natural sorting order, whereas comparator meant for customized sorting order. comparator metaphor customized sorting order. Okay, like you have to, okay, this is the most valuable bit for the exam, for the interview room. Okay, make sure you should aware, sir, what is the difference between comparable and a comparator? Now the basic idea, one line answer you can able to answer. Are you getting at this point? You had better to highlight this one. Comparable metaphor default natural sorting order. Comparable metaphor default natural sorting order, whereas comparator metaphor customized sorting order. Comparator metaphor customized sorting order. Comparator metaphor customized sorting order. Customized sorting order, like the most valuable concept. So now comparable, anyway everything is going to be happen internally, but comparator is the concept what we have to start, what we have to do explicitly. Completed, right? Now keep submitting comparator, keep submitting comparator.